useful online sources. So CSU library, it subscribes to these sources of information, and there are some others. So you will find some links on the CSU course site. And I will need a progress report on November 18th, and the final report will be due on December 9th. Now, in most cases, the term project and research, they are the same thing. So basically, although theoretically, I suppose you could do them separately, but usually it's the same thing. So when you submit your progress report on November 18th, so include some ideas about what is the new idea that you want to investigate. And your final report is going to be your final report for both your term project and your research. And on the course website, you will find some details and you will find some instructions. I have a suggested format, the IEEE conference format, and it turns out that it makes it easy for people to write papers using the IEEE conference format. So I provide a template, and you can use that. Now, with option 2 is project emphasis. So some of you may want to consider option 2. In option 2, there is a more emphasis on the project. So project is 55%, and the tests have less weight. You still have to take tests, but the tests are 24-hour take-home tests. So basically, you will come here, just like others would come here to take the test here, but then you can take the test and submit it within 24 hours. But here I would expect a lot more work in the project. So this may be suitable for someone who has already developed a substantial interest in a certain project and already has a significant background. So it would seem that option 2 would seem like more work, because you still have to take the tests, so you still have to prepare for them, and you have to do a lot more research. However, some students occasionally choose option 2 because it's more interesting, because maybe they want to emphasize the project part of it. Any questions or comments so far about evaluation? Okay, let's talk about grading. So we have these grades. Now this is a 500 level class. So the grading is what is appropriate for 500 level. So basically grades of interest are A minus, B plus, B. So B is satisfactory, and B plus is good, A minus is very good, A is excellent. Now since this is a 500 level class, so this is an advanced class, so most students, they try to work for the best grades, and so my expectation is that most of the students would be working towards an A or A minus, but it's up to you to, I guess, do as well as you can. But these are the grades I would normally consider for this class. Other grades still apply, but this is satisfactory, so if somebody has less than satisfactory performance, one could get something lower. Now there is a student information sheet. So since two of you are new, so you should take a look at this student information sheet for the computer science department. And it basically outlines the policies of the computer science department. Basically it defines what is cheating, attendance policy, general expectations. So an interesting thing to read, although there shouldn't be any big surprises, but those are the department policies. Any questions or comments so far? Let me start by introducing myself. So my name is Yashwant Malaiya, and I'm a professor in computer science department. I have my PhD was in electrical engineering, so I have an electrical engineering background, but I still do some research in hardware, and I collaborate with some people in electrical engineering. But for the past 20 years or so, my areas of research have been focused on software reliability, software testing, security, quantitative aspects of security. So if you will go to my web page, and if you will click on, there's a link regarding publications of our research group, you will see some of our papers there. Incidentally, Angel here, he's taking a recording. So he's going to be recording the lecture, so he's not going to be recording you. So basically the idea is that you will, we wanted to experiment with recording and see how well it works, and maybe put them on the course website. And so that's a new experiment, and maybe we will fine-tune it as we go along. He's incidentally a PhD student, and he's working on some of the quantitative aspects of security. Now let me give you this outline of topics. So basically, it basically describes the objectives, and fault tolerance a while ago used to be kind of an exotic area. It was something that you needed for avionics, you needed for space missions, you needed it for telephone switching, and that is where some of the early work was done, maybe 2-3 decades ago. But then today it is basically mainstream. In everything, in almost every field of computing, there is fault tolerance. And here, when we say fault tolerance, we mean what do we do about faults? And there are a few different approaches, as we will see. And I wanted to try the slides. Okay, I guess that time is not correct. I should not look at that clock there. Okay, so let's take a look at this. And let me see how the slides work. So I have gotten this warmed up now. Go to laptop. see something happening there. I see the light. Oh, I think I have to do this. Okay, you see something there? Okay, so let me, I will let you look at this list of topics. Now this is incidentally a kind of a wish list. I wish we had time to do all these things. And I think we are not going to have the time to do everything. But if we had, this is what we would want to do. So last few things, last few topics we will probably not get to. So basically, students, after having taken this class, they will be able to understand techniques to model faults and how to test for faults and how to evaluate the effectiveness of testing and evaluate reliability of systems when there are permanent failures as well as when there are temporary failures. And the students will be able to determine applicability of a specific type of redundancy, basically to combat faults. And we will take a look at spatial, temporal, and procedural redundancies, and assess the relationship between software testing and the number of defects remaining. And topic outline. So here you will see, we will start with digital circuits. Now digital circuits are a nice example. Many of the things that we will say about digital circuits, they actually also apply to software. There are some significant differences, but it turns out some of the testing concepts are actually generally applicable. But we will use hardware as our example. So we will talk about digital circuits. We will talk about testing, trying to find faults, and we will see how we use fault models to simplify the problem. And we will look at ways to generate tests, testing of sequential circuits, and we will look at fault modeling at a higher level. Now some of our early discussion is going to be deterministic. And after that, we are going to be looking at things from a probabilistic point of view. So we'll have a quick review of theory of probability, basically some of the results that we will be using later on. And we want to look at black box testing, including random testing. We want to look at the theory of reliability. We want to look at how do we evaluate reliability in systems where you have redundancy. We want to look at software reliability. Now ideally, your software should not have any defect, but as you know, for any software that is of reasonable size, there's no such thing as defect-free software. So we will look at how do we characterize the reliability of software and what we know about defects in software, and how does the reliability of a software grow as you test it and debug it, and how can you use coverage as a metric for software. We will also use a coverage metric for seeing how well you have tested hardware. And time redundancy is when you try something a few times and issues in implementation. Now, coding theory, cyclic codes, these would be nice